Hello, YouTubers. This is a new session in our AI journey where we get to talk about one of the cutting edge, bleeding edge kind of corners of AI, which is agentic AI. Everyone now, if you go on any social media platform and type AI, you're gonna find people talking about agentic AI. Agentic AI, it's still very raw and new, and people are trying different things to kind of make it more predictable. They're architecting solutions around agentic AI that makes it more solid and more for the enterprise and production, but it's still maybe 80% there. It's not exactly something that you would trust 100%, the same way you would trust an API calling a database that will respond back with specific data based on the query. It's not there, right? It's not at that satisfaction level, but it's quite impressive and it has good usages. It has places where you can use it when it's kind of less critical. You're not basically going to try to kind of deploy agentic AI for performing a surgery on a person. That's not the right place for that. Probably not even the right time. But agentic AI, think of it as an assistant, right? A very smart assistant that you give them a task. You give them an ask, right? And they'll take that ask and they'll break it into tasks and then take these tasks and try to kind of finish each and every one of them, regardless of what the outcome may be. So this autonomy aspect of agentic AI is to be able to go and say, okay, you asked me to go find data for XYZ. I couldn't hit the database. The API is down. Can I hit the database? Can I find files that have the same information? It kind of thinks on its own and tries to solve its own problems on its own. So it has this kind of autonomy, which is super important. It also has this idea of self-evaluation. It kind of is able to kind of evaluate, is the response, does this task actually complete? Have it reached and achieved the objective? And then it keeps correcting itself until it reaches that particular objective. So let's jump into agentic AI, and then I'm going to show you how to run agentic AI offline, away from the cloud, away from everything and everything. So, okay, first thing that I want to kind of focus on, when you think agentic AI, think in simple three terms, three things that every agentic AI has to have, right? Let's kind of make the font a little bit bigger here so you understand what I'm talking about. 25. Okay, number one, autonomy. Autonomy, just like I talked to you. Autonomy is basically to be able to go and say, my agentic AI, can independently make decisions, create its own tasks based on the input, based on the objective that you gave to it, no problem, right? Number two, reasoning and adaptation. Reasoning and adaptation. What does that mean? If it goes and makes a task and takes a task, it tries to use reasoning to interpret the user's input, solve problems, try to kind of, handle what's happening in the environment where it's trying to achieve a goal, right? Until it kind of balances. Think of it as like it's balancing its own act until it gets to, a satisfactory result, right? So the reasoning and adaptation. And then last but not least is the goal-oriented behavior, right? So agentic AI focuses on one thing and one thing only, to get the goal, whatever you asked of it, to be done. So think of it this way. If you have an ask in here that says, get me some details about Paul, for instance. Okay, so I want some details about some guy named Paul, right? What it's going to do, first of all, in the autonomy area, it's going to go and say, well, autonomy wise, I need to break this into tasks, right? So search for Paul, what are available resources? So there's a SQL server that I can hit to find some information about Paul. Maybe there is a, bunch of files that I can find information about Paul. Maybe there is a APIs that I can call to find information about about Paul, right? So these are, things like that would kind of resemble the autonomy because you didn't really tell it specifically, go look in SQL Server. You're just telling it, go find me information about this guy and let me know. Okay, this is that part. And then, okay, let's assume you found some details, right? You move on to this next phase where you basically go and say, I need to reason this. What is the reasoning, behind this? Is the outcome of hitting all these different endpoints, does it actually work? Did it actually come to the place where I want it to be? Well, this is where you basically go and say, in this phase here, you basically go and say, does it meet expectations, right? Does it actually meet expectation? Is the results enough? Do we have enough results, right? Because you never told it what are all the details that you want about Paul? You're just telling it, give me some details about Paul. So it'll go and find enough results. It's trying to kind of evaluate and self-correct, right, to make sure, it's actually getting you the details that you need, right? And then lastly, goal-oriented behavior. What is this like? Retry functionality, right? Self-correcting, or basically what I would call, I'll just say self-correcting and handling issues in general. Okay, the database is down, the results are not formatted properly, I couldn't really execute this task. You don't have to think about the problems that it's facing. Assume that you're a CEO in a company and you have this assistant and you're telling them, go get me some coffee. Right? Okay, they go to try to get you some coffee, but the coffee machine is broken. Okay, they go downstairs, they go to the shop next door, and the shop next door has a lot of people in it, so it's going to take too long. They go find another shop, to find, lesser queue in there, make sure that you have the right order, and then they get you the coffee. All that reasoning and self-correcting that's happening, that's essentially what agentic AI does, right? With the least amount of human intervention, it will go from one phase to the next phase to the next phase until it's able to kind of give you all the details that you need about a particular task and a particular job. Okay, what's the architecture of this look like? Let's jump into the architecture of this. Okay, so let's assume that you have a prompt. This is the simplest possible way I could think of to run agentic AI offline. So you see like the building blocks of it. Assume that you have a prompt. So it all starts with a prompt. I want to know everything you have about a certain person. Give me the students with the highest score, whatever the case may be. Okay, so you have a prompt. And this prompt will go into some model. It's very important that your model is built to kind of handle certain scenarios and certain ideas. Like if your model, like if I tried with Tiny Llama something like this with Agentic AI and it failed miserably, it didn't really do what I wanted it to do. Mistral did much better. So you have to be able to think about which model actually is the right model that'll do that for me. The model main responsibility is to go and break your prompt into tasks. Now focus with me on this one because this is where it gets interesting, right? So tasks. Task 1, task 2, task 3, doesn't matter. Stuff like that. Okay? Here we go. Okay, so I have tasks. So the model decided in order for it to complete your prompt and complete your ask, it needs to break it into one or many tasks. In the example that I'm going to show you today, the actual coding example, is going to be just one task. It couldn't be interpreted in any other way, but we're going to play around with it and try to break it, so you see, what I mean by that. Okay, these tasks will try to find APIs. It doesn't have to be an API, but if you're doing something serious and it's gonna go and do something for you, it's probably gonna be API. So hit the API, hit the APIs, across the board here. Okay, great. So it hit a bunch of APIs. This is at scale, right? And then like an enterprise architect for AI will show you this stuff and be like, here's how we scale this thing. Okay. And then these APIs will return a bunch of results, right? So let's just assume here, I'm gonna kind of for the purpose of simplicity, I'm gonna just go here and say results like that, results. This is where you kind of start the reflection aspect of it. This is where you go back and say, do these results actually meet my expectations? Did it actually do what I want it to do in terms of like completing the task? We don't know, though we need some evaluation to happen. This is the reflection part, right? This reflection part will go all the way down here. Oh, sorry. Here we go. We'll go all the way back here and say, hey, reevaluate, right? And it doesn't have to be the same model that's reevaluating, but for the purpose of simplicity, I'll just go here and say reflection, and reevaluation. And I'll show you a very good example of that in the code example that I have for you here today, that what it does and what it's actually doing. Okay, so this is reevaluation, reflection, evaluation. And based on that reevaluation, you could determine that this is the terminal phase, that you actually reach the end result and you can go back to the user. So this is final. Or you need to kind of reevaluate and try to work on the problem. Remember, like assume that the first task was, okay, you need to make coffee. Let's go to the kitchen. Oh, the coffee machine is broken. What other APIs, what other options do I have to be able to kind of achieve the goal and handle issues and still reach out to that goal. That's what makes Agentic AI super awesome because with the least amount of work, it'll kind of complete the task for you without you having to debug through it and see why the database didn't work out and whatnot. It's not perfect. I'd say maybe 70, 80%, but it's definitely something that you want to consider. To make this much simpler approach, I'm gonna copy just this here, just a much like really anemic kind of much tinier kind of thing. And I'm gonna go here and I'm gonna show you example. That's what we're gonna implement today is basically when you're doing it in SQL. What does it actually look like if you do it in SQL? So I'll go and say find students with score over 120, right? So that's a simple prompt that I'm sending in here. And what this guy is going to do is going to send it to a model, right? And the model will basically prompt and say generate SQL query. So, right? So basically, let's say I just evaluate and extract tasks. And this here will be like, generate SQL query, right? The SQL query will go and hit a SQL database. And then the SQL database will return a result. And the result will basically be reevaluated. So this guy goes right back into here and says, did it meet the expectation? Did it meet the expectation? Did it meet the expectations? Right? Now, there's a lot of trust here on the fact that what you would consider as a human being something that meets your expectations or not, something about the prompt. And don't take prompt engineering lightly. Just because everyone is prompting, it doesn't mean that they know what they're doing, right? Prompt engineering, I mean, I have this book in front of me here for James Phoenix and Mike Taylor, right? Prompt engineering, just about prompt engineering. Read about it, see what it's talking about, how you can communicate with AI. I mean, AI is trying to reach you in terms of natural language, but you also have to fix how you think and engage with AI so you can actually get the best performance. So it's really under the hood, software engineers writing code to make sure they hit AI in the right way and get the right proper results. If your query is not right, your architecture is not going to work out, right? So this is basically what we're going to try to do today. I created a simple SQL database for you here. It's called Students School DB, and School DB has a bunch of rows in it. As you can see here, Hassan, Kailu, Paul, Zafar, whatever, and it has bunch of names and bunch of scores in there, right? And these scores, its main responsibility is that I'm gonna give it a bunch of tasks, and I'm gonna tell it, okay, as a tiny single offline agentic AI, architecture, go ahead and let's perform tasks that fall within that context. But trust me, this is a very tiny, like it's basically like teaching one letter in the alphabet, not even a whole word. It's one letter, right? So let's just go ahead and do that. That's exactly what we're gonna do here. Okay, we're gonna teach it. We're gonna talk to AI. We're gonna teach you about a particular resources that it can work with, and then see if it can actually work with these resources successfully. So I'm gonna go ahead and create a Python file in here. I'm gonna call it agentic Python, like that. For starters, what I really want to do is to pick up the right model, right? The right model for you here would be the Hugging Face Mistral model. It's super important that you understand and pick up the right AI model for you. So I have the CLI enabled. This is not a tiny, like, don't be fooled by how fast this thing is downloading. This is a 4 gig file. So it's gonna take you some time if you don't have a faster internet connection, but I promise you it's totally worth it for your learning. I mean, start it and just go make some tea or take a shower or something. It doesn't matter. Do something interesting. Okay, so I have this guy, so I should have something here called models, and this is my Mistral kind of instruct AI model. Okay, let's start kind of bringing in some code, and let me explain each and every one of these code. First of all, we want the imports. Okay, we want something that talks to a database. Great. We need to install these dependencies. This guy will install missing packages for me out of the box. Let's do that. So install all missing packages, llama.cpp. Great. There we go. Great. Let's do that. Should we do it old school? Let's do it old school. So clear pip install llama cpp. Is it like that? Let's see. what's the llama cpp package? Pip install llama cpp. Yeah, there. Llama cpp python, I think that's what. There we go. All right, looks good. Okay, so that's one piece. And then the very next piece, we're going to define a bunch of functions that we're going to need very soon. For starters, how will you, like, go back to the architecture here, how will you teach this thing to query a database or perform things about the database if it doesn't understand what the database schema is, right? So I need a function in here that teaches the AI model about the database schema that's going on. So let me kind of pick this code up in here and just slam that in here. Let's just go through it real quick because explaining this is much easier than just typing it from scratch. I'm also not a Python guy. Like hopefully we'll be able to develop .NET wrappers around all that stuff. But I'll explain it to you. Basically what we're doing is that we're getting the connection. The cursor is basically, think of it as the navigator of the database or the executor of the database, right? And it goes and says, this is a raw SQL command that basically will get you every single database table and the properties of this table. So give me the table, give me the catalog, give me all the properties here. And then we're basically getting each table and fetching all the details, every column and the column type. Why is that important? Because if I tell it, like for example, if I tell it go ahead and find me the student with the highest score, it needs to kind of evaluate, see all the tables that matches that student, and then find all the properties that match the score. And it doesn't have to be one for one, right? But it needs to know what your database is. Otherwise, it's just going blind into a storage system that it doesn't understand or know how to communicate with. Okay, so that's one part. That means we need to kind of initialize that cursor at some point in time. So that cursor that we passed up here, that needs to have the connection details and whatnot. Okay, great. The second part of this code is to basically go and say build the large language model prompt, the LLM prompt. And this is the interesting part. Agentic is all about prompting, right? If you don't, like I said to you, prompt engineering is a serious, serious thing and it plays a crucial role. It's not just about you kind of telling it rewrite something as a rap song or whatever the case may be. No, it's actually becoming more and more fundamental to interacting with AI. And it might kind of have some people think about how can we kind of find some standardization and formatting to the AI models that we're communicating with so the outputs are predictable. This is going to build a prompt. Now bear with me here. This guy does two things actually. The first thing that it's doing here, it's basically saying you're getting the question, you're getting the database schema, but also there's error message and previous SQL. Why are these two are here? That's the self-correcting part. Like if you hit the database and it errors out, it's gonna try again. Let's say the database is down or the query had some funny character in it or whatever the case may be. It's gonna try that again and it's gonna try to do that again. Okay, so in here, if there is an error message that actually happened, then go ahead and say, here's the previous SQL that you generated, the query that you generate to complete the task, and here's the error that we received from the database. Try again, only use tables and columns listed in this schema. So this here, you're assuming, this is the prompt engineering aspect of it, you're assuming that, a part of the hallucinations that's happening in the model, that it didn't identify properly the tables and the columns listed in that schema. You're posting the schema, you're posting the question. So that's when there's a failure. That's the self-correcting part. Okay. If there is no self-correcting, okay, we're talking to a database, go ahead, there's a query, make sure you only use tables and columns, never invent or singularize table names, output only, stuff like that. Don't try to come up with table names, just go ahead. Okay, so these are the instructions, right? This is basically how we're telling it. In case, like for starters, this is how you're going to ping the AI and basically tell it this is how you're going to process this. But in case of failure, you want to also come back to it and say, here's the previous SQL query, here's the error message, and here's the schema. Okay, so that's another function that we needed. The next function, this one is very, very interesting because AI, when you prompt AI, it's gonna bring a lot of garbage, right? It's gonna do a lot of garbage. Like sometimes it's gonna come back and give you the right query, but on its own, it's gonna give you some additional text that's irrelevant. And if you rely on this text to execute and call the actual API or call the server, the SQL server, it's not going to work because your query now has more instructions in it and more content in it than what you're expecting. For the time being, we're really restricting it to select so it doesn't kind of delete stuff by mistake and whatnot. That's another risk handling thing that we're going to have to think about when you're architecting agentic AI solutions. Okay, last thing, let's start executing. This is the main script. So step number one, we need to connect to the database. Okay, so connected to the database. There's a bunch of details. This is my local server that I just showed you a second ago, right? That's the local server that has these details. And then let's bring in the model, the Mistral model that we get. Remember, model Mistral, we downloaded this guy. Great. It's a GGUF, model. Not all the models that we're going to interact with is a GGUF based. GGUF, the G in the GGUF stands for the name of the guy that invented the thing. I think his name is Gregory. Gregory. I'll find his name, but it starts with Gregory something. And then there's the question. This question here, we can make it anything we want. For the time being, I'll just say, find me the score of Paul, right? I'm not saying anything. I'm just saying find the score of Paul, right? That's all I'm doing. That's the interaction. So the task here is to go and understand the task, break it into SQL, go hit the database, bring me back some details, and respond to me, right? And then lastly, we need to kind of be able to kind of like get the schema, introspect the schema, update the schema, and then basically set up the retry model. This blob of code is a little bit larger, but I'll explain it to you real quick. What this code, of course, this code will be shared. You can use it, build it, do whatever you want with it. That's not a problem, right? So here's where we are. I basically went and said, get the schema. Here's the retry logic. So when this thing fails, retry. That's fine. We're gonna go and extract a valid schema. So let's get it from the top. You got the prompt. Remember, we built the prompt. We sent the prompt to the large language model, the Mistral model, and got the response. And then we're calculating the attempts. It's just logging. You don't have to have that in here. That's just for you to kind of understand how the system works. Extract valid SQL. So we're assuming that the response that came back from the large language model has SQL in it. And this SQL, we're extracting it, and then we're executing that SQL and getting some data from if the data, sorry about that, my headset went off. So if the data is not present, then we're gonna throw an exception and say something is wrong, break and retry. If we couldn't hit the database, we're gonna add the attempts. That's the self-correction part of it. And then lastly, I want to summarize the details. I'm going to basically go back and say, here's the summary of whatever, right? Remember, I just wrote this user question, just out of the blue. I didn't actually plan for this. It may or may not work. Let's find out. So I'm going to go and run this. There you go. Mistral is very heavy. Even on a monster machine like the one I'm running this on, it's still heavy. So look, it basically went and said, select the score from students. Well, that's 100% correct. That's exactly what you want to do. And then we're waiting for it to execute. So now it's going to try to hit the database and get these results back. That's the self-reflection part. Based on the query provided, let me kind of take my face off here. Based on the query provided, the results indicate the score of 200, and that's true. That's, this score could represent various things, but generally, see now it's starting to kind of, out of like it's kind of trying to, from its mind, trying to add more than what I asked for. But this is literally what just happened. Paul does have a score of 200, right? Let's ask it a harder question, right? Let's just go here and say, find me all the students that have a score larger than 150. Let's run this guy again and see. Here we go. Attempt 1. Is the query correct? Yeah, it said based on the results, Paul and Abdul Samad have achieved a perfect score of 200. Well done to both of them. So it's basically kind of from its own kind of trying to kind of contribute to the result, but that's basically what's happening. Now, let's give it something a little bit harder. So it's not just one task. We're going to give it two tasks. One task would be to find the results, and then the other task to find the percentage or the average, right? So now there's two tasks, right? So let's go ahead and ask it a question. This is something I definitely didn't plan for. What is the percentage of Kailu's score, right? The percentage, right? You need the average, you need to understand the maximum score, and you need to give me the percentage. Kailu here, we gave him a score of 120. So let's see here what that looks like. Ah, look at that. It started to spit out errors from students, order by score descending. Something is going on. See, we're kind of making it hard for them. There you go. Finally, it reached it. This is a great example. See how it said approximately 15.58% of the score belongs to Kailu? Nah, not exactly the answer that I was hoping for. It's not actually quite correct, but we also needed to make sure that your prompt is also correct for score, assuming that the highest score is, let's say, 200. So if the highest score is 200, what would Kylo? So you see that self-correcting part of it. I'm so glad it did that because you get to see how it's trying different attempts and adjusting the query and making sure that it actually can achieve its goal the way it's intended. So here we go. Here we go. Here we go. Based on the data provided, approximately 60%. That's absolutely 100% correct. 120 out of 200. I think it's about 60%. That's right. So this is exactly this is exactly what agentic is. What we basically did is that we gave it a task. It generated a SQL query. It ran a SQL. In our case, it generated a SQL query and it ran the database, but also run calculations like that, and it just used its own kind of model to kind of do that. So how it aggregated the results and put it right back in there, that's the ultimate goal for agentic AI. I hope I hope you understand and you find this interesting. Of course, at scale, if you're trying to, ideally, your agentic AI architecture needs to be much more standardized in terms of what resources it needs to talk to, right? So you should be able to kind of completely decouple and abstract the part that generates a query from the part that actually connects to the database as a broker or whatever. And also, it needs to know that in general, how to interact with this resource, right? Something needs to translate, the part that's breaking the tasks from the part that's actually hitting the resources. Sometimes it's not always hitting a resources. You're gonna let it kind of make that decision on its own. But also part of the orchestrator of this whole architecture is to be able to go and say, what are the available resources? Let's like remember that assistant example where they go to the kitchen, they couldn't find the coffee machine was broken. They went downstairs. The shop was busy. They went in another shop. So this kind of reflection and reevaluation part is super important in agentic AI. This is just a very surface area kind of thing, but it helps you kind of run offline, run local, be able to kind of experiment with AI. I hope you find this kind of useful. I can't wait to show you more about this AI journey and endeavor. If you have any questions, comments, concerns, please feel free to drop a comment in the comment section. Don't forget to like and subscribe. Thank you. Take care.